Thank you. Okay, welcome everyone, and thanks for being here. I would have loved to be in person, but probably next year. Let's cross fingers. Okay, so my name is Rob. I work at the New York Times on the main reading app as a software engineer on, of course, on the Android platform. And I'm so happy to be back at Droidcon Italy. I don't know for how much time have I been here? I don't remember.
And I'm Daniele. I'm an Android developer freelancer. And yeah, I've been at Droidcon Italy for, I don't know, since 2014, I guess. So it's great to be here this year as well, even if not in person.
Yeah, okay. Let's get rolling then. So first, if you have any questions, do you want to ask during the talk, and well, you don't want to slip them out of your mind, just connect to Slido and use this code. We'll see the questions live and we'll address them at the end of the talk. Okay, so let's get started. Okay, so the first thing, we will be talking about wellness as a concept in tech again. And we divide these concepts into three main aspects that are the three aspects that interest us developers. The first one will be how to track our sleep, because sleep is incredibly important. And we want to test it and see how this API performs. Next, we want to exercise, but we don't really want to record everything by hand. So we'd rather have something that recognizes what we're doing, at least for something that involves moving through space, like running, walking, biking, or any other sport that involve going from one place to another so that our phone can measure it. And of course, since we all are developers and we love this stuff, we also want to record everything in a single place where we can then see afterwards. This place will be Google Fit, because again, we are on Android and Google Fit is our platform of choice. And with that, I leave my co-speaker Daniele talk about Sleep API or exercise probably.
Yeah, actually, I was thinking we just had lunch, so somebody would like to take a nap after that. But let's start doing some exercise first. We can have a nap later. We can sleep later a bit. So in this section, we are going to see how we can track one sport activity, for example, a running exercise. And we are going to see it in different stages. First of all, we want to track the user location. So see during the activity how the user is going to move, how fast they are going to go, etc. Computing the distance while we are getting updates on the user location. And finally, we can see also how to access the step counter. So for example, in case we want to display the number of steps done during the activity, or maybe just during the day, if you want to keep the user informed about their movement, even if they are not doing an active exercise. So first thing we need to do is to get the user location. To do so, we need, of course, a permission to access find location in this case, because we want a good precision on how the user is going to move. It's not enough to have a coarse location. And then we need to get an instance of the allocation service. In this case, we are going to use the fused location provider client, which is a client that uses several technologies in order to give us an indication of the user location as, let's say, as precise as we want. And we will see later in the next slides how we can configure this precision. Once we have this instance, we can ask already what was the last known location. This is an asynchronous task, and on the result, we will get this location with the coordinates, and we can start to see, okay, this is the current location of the user, and when we are going to start a recording activity, this is going to be our starting point. Then we want to create a callback. This callback is going to be used later by the service to inform us when we have a new location result. And of course, inside this location result, we are going to do all our math to calculate the distance, speed, etc., etc. Then we need a request, which is going to be sent to the client. And this is where the real configuration happens. Here, as you can see, we can specify the priority and an interval. Interval is in milliseconds, and it explains, specifies how often we want to have an update. In this case, it's going to be every 5 seconds. And this means that we are going to receive a callback even if the user doesn't move every 5 seconds. Then the priority. Priority, it really depends on the use case, but in this case, we want to be as precise as possible. So we specify the high accuracy one. There are several other values that you can set. For example, you could set a low power one in case you're not interested in timely updates, but you want just an indication of where the user is. Or you could put also a balanced one. And in that case, it's totally up to the system to decide how much power to consume compared to how precise the callback is going to be. In this case, of course, we want to be very precise because we want to know how much the user is running. So let's keep the accuracy. Then we bind the two together and we perform the request to the client, specifying the configuration request, our callback, and a good old looper that maybe you haven't seen this in a while, but it's still necessary for this kind of requests. Okay, in our callback, we've seen before, we are going to receive new location updates. And when we get those, we can simply use the spherical util class, which is a utility class included in the Google Maps API library, which is very handy because it basically allows us to get the distance between two coordinates in meters. So once we have this, we can know how much the user has run since the previous update. So we can get the timely immediate speed. We can sum it to the total distance that the user has done since the run started. And also we can update all the UI and all the statistics for the run. So now that we have the distance and the location, we can of course draw it on the map, or we can get more data about their activity. For example, we can also consider the number of steps done. In this case, we are going to use a different sensor, which is the step counter. And to do so, we need to create an implementation of the sensor event listener class. This is a generic class, which we will see later, which is going to receive updates for several sensor events. To get the sensor that we really want, we need to get, first of all, the sensor manager, which is a system service. So we get it from a given activity or a context. And from that sensor manager, we can get the actual sensor that we are interested in. In this case, the type of this sensor is going to be the step counter, of course. We also need to keep track of an initial step value. We set it immediately to -1, and we will see later the reason for that. Then we need to set up this step counter. And to do so, we basically need to register our listener to the sensor manager. In this case, we need to specify which sensor to use, the delay, and also we need to remember to bind it to the life cycle of our activity. So when the activity is not displayed anymore, we need to unregister the listener. I said before that we needed to set initial steps to a given value. In our case, it was -1. This was done because the step sensor is reset to 0 every time that the device is rebooted. So after the reboot, the step counter restarts. And if you want to track, for example, how many steps the user did in a walk exercise, we need to get the initial steps. And then in our callback, we will get a non-sensor changed event callback every time that the sensor detects some other steps. Here, we don't need to take care about which kind of sensor event this is, because we registered only for the step count. So in this case, we are sure that we are going to get a new amount of steps, and we can sum it to the number of current steps. Also, actually not sum it, but we can make the difference between the initial one and the current one. Okay, so our user went for a good run. Now they are pretty tired. We already had lunch, we said, so it's time for a nap. Recently, a new API was added, which is really helpful for us in order to be able to recognize when the user is sleeping or not. And this is helpful because we can allow user to better track their behavior and understand their sleep habits. This API allows us to receive two kinds of events. The first one is the sleep event, and then the second one is the sleep segment event, the first, and the second one is the classify event. The difference is that the sleep segment is basically the more condensed and polished kind of event, where basically the system is going to inform us, okay, I'm pretty sure that at this point, from this time until this time, you see we have a start to timestamp and an end timestamp, the user was probably sleeping. Probably because it depends on the status as well. It depends if it was successful to determine it. If it was not detected, then maybe it is not something that you should report to the user. And also if there was missing data, maybe this segment was not that confirmed. Which data are we talking about? We can access the raw data that the system is recording through the sleep classify event. This event is way more frequent than the segment one because is recorded every few minutes by the system, and it contains a light level, motion level, the time, of course, and a level of confidence that the user is sleeping at that time. Something that I didn't say before is that all this API works with just the user phone. It doesn't require any wearable or any particular sensor to be attached to the user body. It's just using the phone sensors like camera, ambient light, accelerometer, gyroscope, these kind of things. So the system interpolates motion, light around the phone, and it creates a level of confidence. So light and motion we will see also later, but they are basically from 1 to 6, while confidence is in percentage, so from 0 to 100% of confidence that the user is sleeping. Having these kind of events, they can help us create a good UI and a good summary for the user to let them know how much they are sleeping, how their sleep habit is good, let's say, and also how they can improve it. Let's see now how we can implement it. First of all, we need to check the requirements, and unfortunately at the moment this API is pretty limited as it's available only for devices running Android with API newer than 29. And also it needs Play services because it's all done under the hood by the Google Play services. And so, sorry Amazon and sorry Huawei devices, but you need this to be installed. It's all based on the Play services location library, so that one needs to be a dependency, of course. To receive updates, we need to specify a broadcast receiver, which needs to be enabled and exported in the Android manifest. In this broadcast receiver, we are going to implement, of course, the onReceive method, and then we can use the static methods that are coming from the sleep segment event class and sleep classify event class. Both, they are providing a couple of methods to check if the intent contains some events and to extract them. The kind of events are the ones that we've seen before. So of course, the sleep segment is going to tell us the duration of a sleep session, let's go like this, while the sleep classify event is going to be more low level with all the events that are triggered by the system. We need to specify also, we need to request also the activity recognition permission. So we specify it in the manifest, and that is an activity that is granted by default. But in our main activity, it's also good practice to check it, because the user can also remove it from the system settings later. So we check it, and in case it's granted, we are all good. But in case is not granted, so it means that the user removed it, we need to request this permission. To do so, we basically we can start an intent, we can start an activity pointing the user to the system settings of our application, where they can actually restore this permission, and then be sure that we have all we need to in order to request updates for these sleep events. Then, once the system are all sorted, we can use the activity recognition client to request a segment updates. There is also a request classify event updates, but requesting the sleep segment one is going to give both the kind of events. So this one is the most complete one, let's say. Okay, once we have this, we are going to receive several callbacks. Again, it's a broadcast receiver, so our app is gonna receive it even in the background, and then we can just display them to the user after storing them, for example, in a database or any preference or whatever your app uses, and then we can show it to the UI. I did some tests over the last few days, and I'm gonna show you a couple of graphs that are gonna show how the kind of events and data inside the events are correlated. In this graph, you can see, for example, the amount of light that my phone registered for about 2 days, I would say. Of course, the lower the value, it means that the lower value it was recorded. And remember that the minimum value is 1, not 0. This is the same one related for motion, and you can see that yeah, sometimes the phone was pretty still even in the middle of the day, but most of the other time it was still moving. I think here you can already identify a couple of places in these graphs where there was no light, no motion, and predictably the confidence was pretty high. And in fact, these 3 graphs are basically a summary of the classify events that our app was receiving. But actually, what we really care to show to the user at the moment are the segments. And in this case, you can see they pretty much overlap to what you were expected. So here, you could see that with this API, it's really simple to get an idea of how the user is sleeping, and maybe also it's possible to give them some suggestions if they should do it more or less. Well, less is, I don't think is a good suggestion. Something to bear in mind is that, as I said before, this only relies on sensors that are on the phone. So, for example, if we are at home and we don't have our phone with us, or we fell asleep watching Netflix on the sofa, where the light of the room is pretty dark, maybe the phone is gonna be able to see it, or we could have also a false positive. Maybe if the room is dark enough, we are not using the phone, so there could be confidence that the user is sleeping while actually we were just watching a movie, and vice versa. So it's still a good addition to our tools, let's say.
Okay, now that we exercised and we slept, it's time to record everything that we can record. So of course, to record these, we're going to use Google Fit API, which is not necessarily new, but yeah, it's still kind of new. So the first thing that we need to do is defining a fitness option object. In this object, we're going to add a data type, in our case, the step count delta and the aggregate step count delta. And we need to define for each data type the kind of access that we want to have. In this case, we want to only have read access so that it can be updated if any other app actually recorded anything. Of course, you can not only add a data type, but also some other data sources that are coded inside the Google Fit platform. Then, of course, you need to have an account. And for that, you use the Google Sign-in object, and you get one of the accounts that you have on the device, passing in also your fitness options. Unfortunately, well, since we need a permission, we cannot really rely on the latest addition to Jetpack that would actually slim down our permission request code, because the permission request code is embedded into the Google Sign-in request permission method. Unfortunately, well, this has not been updated yet, but probably in the nearest future. Of course, this doesn't really change from any other permission request. You need your activity or context, a permission request code, and of course, you need to pass some additional parameters that will be needed for the Google Sign-in to work. If you already have this permission, you are free to record or to read, really based on what you defined in the fitness options. And again, well, this is a very simple and straightforward way to get your result. Bear in mind that if this was ever updated to the new Android X Jetpack API, this boilerplate would probably disappear, favoring the new approach where we just have a Lambda and launch the new permission. Okay, so next, well, we want to record our session. There are two ways of doing so. In here, we put as example the fact that we are the app that track everything. So we already have our service that track the users. We draw on a map, we check the steps and everything. So what we do is build a new session, passing in a name. If you use apps like Strava or any that track you while you run or bike, you see that you always have the same name inside the app and in Google Fit. This is the name that you are going to use. Then you need an identifier, which must be unique, otherwise there will be a problem when saving data. And you can additionally add a description. Of course, you want to set the kind of activity that you're recording, and a start and end time. Another way to record a session would be to rely on Google Fit. So basically, you, instead of using a session builder, you record a session and you stop the recording when the session is done. Those are two approaches, but since we are implementing this API, we prefer to actually record our session and then build a session object for Google Fit so we could add all our data. Okay, now we have our session object, and we need to build, well, another request that is a request for insertion inside the Google Fit database. This is pretty easy. You just need to build it, set the session that you want, and just return it. And then, well, you get again your account from the Google sign-in provider, and you now use the fitness object to get our sessions and to insert them. If everything goes as planned, your add-on success listener will be called. Otherwise, your add-on failure listener will be called. A personal advice will be to wrap this code around inside any other object that expose a live data, an observable, a flow, whatever you want, so that it's actually easier to manage from the outside.
Okay, so I think that was it for we wanted to share today.